Welcome to the second video in Unit 2. The title for the unit is Thermal Physics. The first video compared solids, liquids, and gases, and specifically we compared their kinetic energies and potential energies. In this video, we're going to start out with something you are well familiar with, temperature. So intuitively, what is temperature? You know the answer. Temperature is how hot or how cold something feels when touched. But this is not a very rigorous notion of temperature. For example, someone who's in Antarctica, if you take them and put them in a room where the air is 70 degrees Fahrenheit, they might say, "Ooh, ouch, 70 degrees Fahrenheit is really hot. It feels hot to me." But if you take someone who lives in the Sahara Desert, where it's always really hot, and you put them in a room where the air is 70 degrees Fahrenheit, they might say, "Oh my gosh, 70 degrees Fahrenheit, this is cold. Get me a jacket, I'm used to something way hotter." So the problem with this definition, this notion of temperature, is it is not objective. We cannot measure it objectively because how hot something feels could depend on what you're used to. So what is temperature then? If it's not how hot or cold something feels, what is temperature? To answer this question, first we need to know about something else. Every single molecule, atom, compound, and particle is in motion. Even in solids, the molecules are vibrating back and forth. All molecules have kinetic energy. In IB physics, we don't really call things atoms. In this unit, we will later. We don't call things compounds. We don't call things particles. In this class, in this unit, in this particular unit for thermal physics, the one word we use to encapsulate or to capture all of this is molecule. So we say all molecules have kinetic energy. So, for example, if you take a big cup of water and you look at it under a microscope, what will you see? You will see lots of different molecules, which I'll just draw with single dots. Lots of molecules, and every single one will be moving. Now, they'll be moving at slightly different speeds, so they'll have different amounts of Ke. This molecule will have some amount of Ke. This molecule will have a slightly different amount, maybe a little higher. This one's Ke, it's molecular Ke. The molecule's Ke might be a little bit lower. So if you take all of the values of individual Ke, right? You take this value of whatever this molecule's Ke is, you take the Ke for this molecule, you take the Ke for this molecule. If you add them all up and you average them together, you'll get one single value, which we call the average kinetic energy of a molecule in the substance. These brackets on the side, these really fancy brackets, can be used to represent average of. So the brackets say, if you take the average of all the kinetic energy of each molecule, you get one single number. In general, temperature of a substance, temperature, is a measure of the average Ke of a single molecule in the substance. Or we just call it the average molecular Ke. And the word molecular means the average Ke of one molecule. Now, this is the definition of temperature, right? But even with this definition, it's going to be a little hard to measure temperature. Here's why. You can't really measure very easily the kinetic energy of a single molecule. Measuring one molecule's kinetic energy is kind of challenging. But think about how many molecules there are in a single cup of water. You are never going to be able to measure every single value of kinetic energy for every single molecule. That would be impossible. So you can never take an average, and you can never measure temperature this way by measuring the Ke directly. So how can you measure temperature? You have to do something different. You have to measure some other physical quantity that changes with temperature. Here's an example. An old-fashioned mercury thermometer consists of a long tube with a little bulb at the end, and then inside is mercury liquid. Right? And let me make it, red is good. Mercury liquid. So if you take this thermometer and you put it in a really hot room, then the mercury inside gets hot, and when it gets hot, it expands. That mercury, when it expands up because that's the only place where there's empty space. It expands, it rises. The column of mercury rises. So how does this particular device, this old analog thermometer, how does it measure temperature? It does so indirectly. It measures temperature by measuring the height of the mercury column. That's how it measures temperature. Mercury has the symbol Hg. So it measures temperature by measuring a different physical quantity. The higher the column, the hotter the temperature. Now in IB physics, there are two temperature scales that we are going to be using to quantify temperature. One is the Celsius scale, and the other is called the absolute scale. The absolute scale uses Kelvin. Now here's how the Celsius scale was designed. Mr. Celsius came along and he said, in my scale, 0 degrees is going to be the freezing point of water. And he said 100 degrees will be the boiling point of water. The Kelvin scale, designed by Lord Kelvin, is a little bit more complicated. It goes back to what we were talking about earlier. The absolute scale was designed so that the temperature is proportional to the average molecular kinetic energy. In other words, absolute temperature, and we can call it also Kelvin temperature, is proportional to the average molecular Ke. So temperature and average molecular Ke are equated only by a constant. And that's how absolute temperature was designed. So under this temperature scale, a molecule will never reach 0 K because molecules never have 0 kinetic energy. Molecules never have 0 kinetic energy, so temperature never gets to 0 K. 0 K is called absolute zero. The last thing in this video is converting between the two. This is easy. You know how to do it. The temperature in Kelvin is found by taking the Celsius temperature and adding 273. For example, if the room, or the water, let's say, the water is at a temperature of 30 degrees Celsius, and you want to know, what's the Kelvin temperature? You would just take this equation, and in place of T sub C, you would insert 30. Notice I've dropped the units. And then you would add these together to get 303, and you would tack on the new unit, Kelvin. So units don't really work in this equation. We just sort of ignore the units during the, we ignore the units until the very end, and then we rewrite the new units. So this right here is how we convert between the two.